Good morning. This is Tom Sorensen from Hyperion Research. I'm an analyst here, and today we're going to be talking about the intersection of AI and HPC and some of the things that we've come to understand and expect from this intersection. So just to jump right in, um, we like to consider this growing AI and HPC intersection kind of a new category of HPC workload entirely. HPC users are adopting and integrating this tech at a high rate. Many methods and models are kind of being given attention and their time to shine, but large language models or LLMs are drawing particular attention, especially among HPC users. Um, Recent surveys that we've conducted indicate that around 90% of HPC users are currently or are currently planning to use AI methods for some of their workloads. Um, and here we can see that these AI methods are introducing some new demands on sites. We have hardware demands like job-specific processors, new kind of interconnect demands based on data transfer needs, software like how to manage the data, queuing, development tools for models, and this new technology. And then of course with all kind of budding technologies that kind of expand at this rate, there's an expertise need and a demand for expertise. You have all these hardware and software tools out there. You have to be able to procure them strategically, maintain things, troubleshoot problems, etc. And then, as is somewhat unique to AI, we have regulatory concerns that sites and users have to kind of keep up with: data provenance, where data is going, who it belongs to, and when, privacy issues, and of course the kind of legal landscape that AI has found itself in as well. Um, so I mentioned LLMs before. Here's kind of framing some of those technical requirements. We have it broken down into these three main pillars here of compute, the absolute number of floating point operations needed to train an LLM. This is a fundamental need of creating LLMs, as well as a data set size, input data set for training. These things are trained on massive data sets, but it's not just about the size, it's about the accuracy of the data. It's about making sure that it's representative of the set that you're trying to look for and its quality, and that all of its ownership and privacy issues have been taken care of. So data set is a huge deal, and of course model size, the number of parameters in the model, it has a huge role to play. The more parameters, the more nuance the model can understand. The data, and the more nuanced and kind of dynamic the outputs can be if we're talking some sort of generative output. Um, and ultimately, kind of the more we see these LLMs and AI models kind of onboarded, the more they will define the necessary HPC specifications that they will run on. And so they really can have kind of that influencing uh, effect moving forward as things get onboarded more and more. Um, just a little bit of a visual here on the left here. We have this yellow block, which is kind of like the pre-deep learning era. Flops requirements for training a model doubled about every 2.13 months. Obviously, there's not a lot of data points here, but we can see a nice, kind of uh, subtle uptrend. And then, of course, once we enter this blue rectangle, the deep learning era, flop requirements for training a model now doubling every 5.6 months, which is roughly 11 times faster than the HPC top one LinPack performance growth rate. And so it kind of introduces this kind of juxtaposition of growth and potential, needs down the line of the requirements for training these models is increasing at a rapid rate. And it's going to that's a requirement that is increasing ever forward. And so in a recent study conducted by Hyperion, an internal study, we surveyed HPC users leveraging LLMs and kind of what they're up to, what their plans are, and how they've integrated them. Here are some key findings from that study. I haven't pulled everything. You can see this is not 1 through 10, but I just kind of pulled out some of the interesting ones. These users consider it to be an important emerging asset for their HPC activities. Um, and they're looking at a broad range of LLM related end uses. This is not a pinpoint accuracy type of application. It's being explored in many avenues of end uses, and many prefer open source in terms of accessing software and development tools. It's an exciting field for many, and there are many contributors to the open source ecosystem, and so that open source kind of environment is very healthy, and there are a lot of amazing resources there. Um, And survey respondents showed an interest in pretty much every part of the life cycle of a large language model, developing models themselves, or fine-tuning foundational models that they have, acquired elsewhere, or just integrating them into existing workloads, and so on. Every kind of part of the life cycle of an LLM is interesting to these users. So just a little bit more visualization. This is a bit from our forecast here. We can see total HPC enabled AI and the total HPDA AI server revenues here are the ones that are trending upwards. And then we have the traditional data science, which is non-AI HPDA, having a bit of a trend downwards over these next 5 or so years. And something important to remember, in addition to this kind of strong uptick in the AI HPDA server revenue, is this downward kind of trajectory of traditional data science is actually more explained by these upper two, which represent AI in HPC, kind of subsuming these traditional data science roles. And so they are the jobs, and the traditional data science is not, these jobs are not being done less, rather they are being done either with some sort of integrated AI acceleration or some other kind of ameliorative um, integrative thing involving AI, which would kind of bump it up into one of these other upper lines here. And so kind of just to put everything together in terms of how these models and how AI and HPC is kind of changing the landscape. This is some analysis released by Riken concerning the Fugaku machine, and kind of a theoretical scenario in which the Fugaku machine would be training a GPT model. And according to their analysis, kind of comparing the Fugaku machine, which is CPU based, to the OpenAI system used to train GPT 3.5, we can say 3.5, we can see 3.5 estimated 4.5 days at peak performance, and that would be times two at an average performance. And then if you look down here, Fugaku, their estimate would be 32 days for the same job at peak performance, and that would be jumped to a times 10 in the normal performance. And so with the GPT-4 row here, we can see that from 45 days to 328 days. And once that peak performance is brought to a realistic understanding, again, this is the Riken analysis, the amount of time difference it takes for a traditional CPU-based supercomputer versus something that is GPU-based and specifically designed for AI training, it's a massive difference in time. And this analysis by Riken is demonstrative of the forces that are encouraging HPC and HPC design to integrate more job workload specific accelerators specifically related to AI and large language models. And so with that all considered, I will pass it off to my next teammate here. And I encourage you to email me, email us. Here's my email and of our CEO, Earl Josephs. And if you have any questions or comments, or just want to talk to us about anything going on, we'd love to hear from you. We'd love to talk with you. And have a great day. Thanks so much.